Welcome to this presentation on finding the longest subarray with an equal number of zeros and ones and how we can solve it efficiently using hash maps. Let's dive into the problem and understand how we can approach it step by step. We are given an array consisting of zeros and ones. The goal is to find the length of the longest contiguous subarray in which the number of zeros is equal to the number of ones. For example, if the array is 1 0 1 1 1 0 0, the output would be 6, as the subarray 1 0 1 1 1 0 has 3 zeros and 3 ones. In this example, the input array is 1 0 1 1 1 0 0. By carefully selecting a subarray, we can find that the longest subarray with equal zeros and ones is of length 6. There are also constraints to consider, such as the size of the array, which can go up to 1 lakh elements. Our solution needs to be efficient enough to handle such large inputs. To solve this problem efficiently, we use a technique called the prefix sum. But here's the trick: we treat zeros as minus ones. This transformation helps simplify the problem, as we can now focus on finding subarrays where the sum is 0. We will also use a hash map to track the first occurrence of each prefix sum, which will help us identify the largest balanced subarrays. Let's go through the algorithm. First, we initialize an empty hash map to store the prefix sums. Then, as we traverse the array, we update the prefix sum by treating zeros as minus ones. For each prefix sum we have seen it before, we calculate the length of the subarray from the previous occurrence of this sum. If not, we store the prefix sum and its index in the hash map. By keeping track of the maximum length of subarrays found, we can get our final result. Here's the implementation in C++. We initialize the hash map with the first prefix sum, which is 0 at index minus 1. Then we loop through the array, calculating the prefix sum at each step. If we encounter the same prefix sum again, we update the maximum subarray length. Otherwise, we store the new prefix sum with its index. This approach ensures that we only traverse the array once, making the solution highly efficient. Let's walk through the example. We have the array 1 0 1 1 1 0 0. First, we convert the zeros to minus ones. So the array becomes 1 minus 1 1 1 1 minus 1 minus 1. Then we calculate the prefix sum 1 0 1 2 3 2 1. As we process each element, we use the hash map to find the first occurrences of each prefix sum. The largest subarray with equal zeros and ones is between indices 1 and 6, giving us a length of 6. Now let's discuss the efficiency of the algorithm. The time complexity is big of n, where n is the size of the input array. This is because we traverse the array once. The space complexity is also big of n due to the hash map used to store the prefix sums. This solution scales well even for large input sizes up to 1 lakh elements. To summarize, we used prefix sums and hash maps to solve this problem efficiently. By treating zeros as minus 1, we were able to simplify the problem of finding balanced subarrays. This approach ensures that we can find the longest subarray with zeros and ones in linear time. making it optimal for large datasets. We have covered the core concepts and solution, but now I would like to open the floor for questions and discussion. As there are any points that need further clarification, or perhaps ideas on how we could extend or optimize this solution further. Thank you for your attention throughout this presentation. I hope you found the solution to this problem insightful. Feel free to reach out if you have any further questions or need assistance. I look forward for connecting with you soon.